Hello everyone and welcome back to the 11th video in our ongoing series. I am Kisle Pandey and today we will take a deep dive into logistic regression and Poisson regression. There are two incredibly powerful and widely used statistical models. If you are looking to predict binary outcomes or model count data effectively, then this session is for you. Let's get started. Logistic regression and Poisson regression are fundamental statistical methods with distinct purposes. Logistic regression is for predicting binary outcomes like determining whether a customer will churn or not. Poisson regression, on the other hand, deals with count data, such as the number of calls a call center receives in a day. By the end of this video, you will understand their mathematical formulation, assumptions, and how to implement them in R and Python. So let's explore their world together. First up is logistic regression. It predicts binary outcomes such as 0 or 1. The logistic function is at the core of this model, calculating the probability of an event occurring. The key formula is Py equal to 1 equal a1 plus e b0 plus beta 1 into 1 beta 0 plus beta 1 plus beta nx, where beta 0 is the intercept, b1, b2, and b1 are coefficients for the predictor variable. The logic transformation which converts probabilities into log R is expressed as log IT in P1 minus P and others. Key assumption includes the dependent variables must be binary, observance should be independent, predictions shouldn't have multicollinearity. Poisson regression. Now let's look at Poisson regression. This model is tailored for count data, such as the number of events happening over a fixed time or space. The core formula is derived from the Poisson distribution. Py equals y in delta ye lambda lambda e. Here, lambda represents the expected number of occurrences using the link function. The equations become lambda, lambda in, lambda 0, lambda 1x, lambda n. The main assumptions are the independent variables must be a count. Observance should be independent. The mean and variance should be equal. If this isn't true, we consider alternative methods like negative binomial regression. Let's move to the implementation. Here's how you can perform logistic regression in R. Load the dataset. Split it into training and testing sets. Train the model using the GLM function. Evaluate it using matrices like a confusion matrix. For example, we use the PIMA Indian diabetes datasets to predict diabetes diagnosis. The step-by-step R code is provided and I encourage you to try it out and learn from it. Implementation in Python. If you are more compatible with Python, don't worry. We have got you covered. The steps are similar. Import libraries like sklearn, load and stitch the dataset. Use logistic regression to train the model. Evaluate it using with a confusion matrix and classification report. Python makes it incredibly easy to implement logistic regression while offering robust visualization options. For Poisson regression, Python provides tools like states models using a dataset, say for bike rentals. We can prepare the data, fit a Poisson regression model, and predict counts using the GLM function. We also visualize actual versus predicted counts to access the model performance. The provided code snippet demonstrates these steps effectively. Here's a quick comparison to wrap up. Logistic regression predicts binary outcomes, while Poisson regression is for count data. Logistic uses the logic link function, whereas Poisson relies on the log link function. Applications of logistics include classification tasks like disease diagnosis, whereas Poisson is used for modeling counts like the number of accidents. Finally, let's discuss the pros and cons in this last slide. Logistic regression is simple and interpretable, but assumes linearity in log odds. Poisson regression is excellent for count data, but is sensitive to over dispersion. Understanding these strengths and weaknesses will help you choose the right model for your dataset. This concludes our discussion statistics and Poisson regression. But we have something so much is practicals and learning practicals. So let's conclude it. We will meet in the next session.